Claude 4 just broke the one rule everyone said was impossible? For years, AI researchers have stared at a hard wall. They said there's a fundamental limit to how far artificial intelligence can reason through complex problems. No matter how big you make the model, no matter how much data you feed it, there's a ceiling. You hit diminishing returns. The logic gets fuzzy. The reasoning breaks down. But 3 weeks ago, Anthropic released Claude 4. And it didn't just bump up against that limit. It shattered it. The demos that started circulating showed something that made experts pause and rewind the videos. Claude 4 was solving problems in ways researchers explicitly said the previous generation couldn't touch. We're not talking about incremental improvements. We're talking about a fundamental shift in what these systems can actually do. Let me back up and explain what that wall actually is. AI researchers call it the reasoning plateau. The idea is simple but brutal. Past a certain point, scaling up doesn't work anymore. You can throw more compute, more parameters, more training data at the problem, and you'll see your gains flatten out. It's like hitting diminishing returns at scale. The system gets good at pattern matching, good at statistical prediction, good at mimicking what it's seen before. But actual multi-step reasoning, the kind that requires you to hold multiple variables in mind, to pivot when new information changes the equation, to explore dead ends and backtrack, to build novel logical chains from scratch, that's different. Previous models would fail on tasks that required more than 3 or 4 reasoning steps in a row. Ask it to solve a logic puzzle with dependencies and it would get lost. Ask it to debug code with nested function calls and state mutations, and it would hallucinate. Ask it to work backwards from a conclusion to find the hidden assumption, and it would give you confident nonsense. This wasn't a knowledge problem. It was a reasoning architecture problem. And everyone said it was the hard limit of the transformer architecture itself. Claude 4 doesn't use a fundamentally different architecture. It's still a transformer, still based on the same attention mechanism that powers every major language model. But Anthropic changed something subtle and crucial about how the model reasons through problems. They implemented what they're calling extended chain of thought training. Essentially, they trained Claude 4 to pause and think explicitly before answering. Not just to surface its reasoning in text like previous models, but to actually dedicate computational resources to thinking through the problem step by step, internally, before committing to an answer. The model learned to self-interrupt, to recognize when a problem is complex enough to require deeper analysis, to break it down into subproblems, to verify its own logic, to catch itself when it's about to make an assumption that might be wrong. In benchmarks, this single change pushed reasoning performance from around 60% accuracy on complex multi-step logic puzzles to 92%. On code debugging tasks that require understanding state across function boundaries, performance jumped from barely usable to enterprise grade. The breakthrough isn't about being smarter. It's about being more careful. It's about taking the time to actually think instead of just predicting the next token. This matters right now because reasoning problems are everywhere in business and science. Software companies are already using Claude 4 for code review and debugging. Not as a suggestion tool, as a primary tool. One financial firm loaded their entire trading rulebook into Claude 4 and asked it to find logical contradictions between rules that have never been caught by human analysis. It found 47. Some of those contradictions have been costing them millions in opportunity loss every quarter. A biotech company used it to analyze their research papers and identify conflicting conclusions buried across their literature. They found a pattern that pointed toward a new drug target no one had noticed before. Educational platforms are using it to generate truly adaptive tutoring. Not just branching on right or wrong answers, but actually reasoning through why a student's approach is incomplete and guiding them toward the right mental model instead of just the right answer. In customer service, it's solving multi-step complaint resolution that used to require human escalation. Someone writes in with a complex issue involving 3 different systems and past interactions. Claude 4 can now trace through all of that, understand the root cause, and propose solutions that actually stick. This is the shift from AI as a writing and summarization tool to AI as a reasoning partner for your actual work. Here's why this is bigger than the last 5 major AI releases combined. Previous breakthroughs were about scaling. More parameters, more data, more compute. They made the model broader. Claude 4 is different. It's about depth. It's about making the model actually think. And thinking is the hardest problem in AI. You can store infinite patterns. You can regurgitate everything ever written. But reasoning requires something different. It requires building new logical structures from first principles. It requires flexibility and self-correction. And once you unlock that, the implications cascade. Every field that depends on complex problem-solving gets affected immediately. Legal research, medical diagnosis, scientific hypothesis generation, engineering design, strategic planning. These aren't things that scale with more data. They improve with better reasoning. The competition dynamic shifts too. For the past 2 years, the AI race was about who could train the biggest model. Now it's about who can make reasoning actually work at scale. That's a completely different engineering problem. That's why OpenAI immediately announced they're pivoting their research roadmap. It's why DeepSeek released a statement saying they're accelerating their timeline. The AI leaders all understand what just happened. The wall didn't just get higher. The entire playing field changed. But this breakthrough comes with real constraints that matter right now. Extended chain-of-thought reasoning is computationally expensive. Claude 4 is slower than previous versions on simple tasks. A straightforward question that used to get answered in 2 seconds now takes 5 or 6 because the model is actually thinking. That's a trade-off, and for most applications, it's worth it. But it means deployment costs go up. A company using Claude 4 at scale has to think about their compute budget differently. The second challenge is explainability. When Claude 4 shows you its reasoning chain, you can follow the logic. But the thinking happens internally too, in parts you can't see. It's like a student showing you their work, but also doing some scratchpad thinking you don't get to inspect. For industries like medicine and law, where you need full transparency and auditability, that opacity is a real problem. Anthropic is working on ways to expose more of that internal reasoning, but it's technically hard. Third, there's the training data question. How do you teach a model to think well? You need examples of good reasoning, not just correct answers. That data is expensive to create and validate. Anthropic had to hire teams of researchers to manually construct reasoning chains and verify them. That's not scalable in the way normal AI training is. The next phase of AI competition is going to look radically different. For the past few years, it's been about raw capability leaderboards. Who has the highest benchmark scores? Claude 4's breakthrough forces the question to shift. It's not just how capable are you, it's how capable are you where it matters most. Reasoning, problem solving, helping humans actually think better. That's a harder thing to compete on. You can't just hire more ML engineers and train a bigger model. You need to crack a different research problem. OpenAI has their O-series models in development that use reasoning internally. Google's DeepMind is bringing their AlphaZero style problem solving to language models. Every major lab is pivoting toward this direction. But Anthropic got there first with a working, deployed system. That's a meaningful advantage. It won't last forever, but it's there. In 6 months, we'll see the second generation of reasoning-focused models from competitors. In a year, reasoning will be table stakes. Every model will have some version of it. The real differentiation will shift to speed, cost, and reliability. Who can do this reasoning cheaply? Who can do it fast enough for real-time applications? Who can do it reliably enough for critical domains? That's where the next battleground opens up. What does this mean for you specifically? If you work in any field that involves solving complex problems, your toolkit is about to change. You'll have a reasoning partner that can actually think alongside you. Not just generate suggestions, but help you catch logical flaws, explore edge cases, and build solutions you wouldn't have found alone. If you're building products, you need to start thinking about how to incorporate this kind of reasoning. Not as a feature, but as a core part of your value proposition. If you're competing in an industry where problem-solving is your differentiator, this shifts your competitive landscape. The companies that figure out how to deploy reasoning-capable AI first get a meaningful edge. The barrier to entry for certain kinds of expertise is about to drop dramatically. A solo researcher could do the work of a team with the right reasoning-capable tools. That democratizes expertise in ways we haven't seen before. This is the moment where AI stops being about scaling what already works and starts being about solving what was previously unsolvable. Claude 4 proved that moment is here. Claude 4 didn't just improve AI. It changed what's possible. For the first time, we have a system that can genuinely reason through problems instead of just predicting patterns. That's not an incremental step. That's a phase shift. The companies, researchers, and individuals who understand this shift and move first will have an advantage that compounds fast. The AI era isn't about being smarter anymore. It's about thinking better. And that advantage is real. If you want more videos like this, subscribe and follow Oops, It's AI. See you in the next one.